Hi guys, back again, and I am ready to get done with chapter 7. So without further ado, let me get that going. All right, well, we discussed the cortex areas involved in movement already. So we are going to head into objective 5, and that is discussing the functions of cerebellum, substantia nigra, and basal ganglia. So let's take a look first at the cerebellum. You know that the cerebellum is involved in movement. And before we've talked about it being involved in balance. We've talked about it being involved in the gracefulness of movement. I want to be more specific now. It's important for sequences of stop and start actions, aim, and timing. So for example, I think I've talked to you before about anything that involves kind of a rhythm. The cerebellum is going to be really important for. And so, for example, just tapping your finger to music or something like that, clapping to music and stuff like that, cerebellum is very important for. There's a test of cerebellum functioning that police officers use because alcohol pretty grandly affects the cerebellum, and that's how it makes us kind of clumsy. And that's the finger to nose test. You know what it is. It's where you held your hand out and then you guide your finger to your nose. Well, this moving your finger and holding it is handled by the cerebellum. And so when that looks a little bit messed up, then they can tell that, in fact, you have had, some cerebellar compromise, probably because of alcohol. It also controls the saccades of the eye, which are fast movements of the eye, saccadic movements or ballistic movements of the eye. And so if the cerebellum is damaged, the person can't move their eyes very rapidly. So we take it for granted that if something happens over here, all of a sudden I move my eyes. But a person with cerebellum damage is not able to do that. And as you may guess, the damage to the cerebellum actually looks like you're drunk. And people have trouble looking real fast at something when they're drunk as well, you might notice. Okay, well, let's talk about the basal ganglia. The basal ganglia comes in 3 parts, the caudate nucleus, the putamen, and the globus pallidus. But we're going to talk about the caudate and the putamen as if they are one part together, so we can kind of combine those, but recognize they're actually 2 different parts of the basal ganglia there. But in terms of functionality, we're going to talk about it as one. So we get kind of a loop of action in the brain where the input from the cortex goes to the caudate nucleus and the putamen. So that is about ordering movement, right, from the primary motor cortex there. And so then that tells the caudate and putamen to get that movement going. And it really has to do with voluntary movement there. So then the output from the globus pallidus, so you can see the caudate and putamen then stimulate the globus pallidus. The globus pallidus then stimulates the thalamus, and then that feeds back into the cortex to regulate those movements. And so, but it works in a slightly complicated way, as the parts of the brain often do. So the globus pallidus, we can start with the globus pallidus. The globus pallidus automatically inhibits the thalamus, okay? And that's going to basically inhibit movement, right? And then what happens is you've got the caudate and putamen over here. The globus, this is silent. The globus pallidus is inhibiting the thalamus, inhibiting the thalamus, inhibiting the thalamus, inhibiting the thalamus. Now, when the cortex says, okay, time for action, the globus pallidus the caudate and putamen now inhibit the globus pallidus. Now the globus pallidus was inhibiting the thalamus, but now it's not going to inhibit the thalamus anymore since the caudate and putamen just stopped it from doing that. And so, so at that point, that's where voluntary movement emerges. So the cortex tells the caudate and putamen to inhibit the globus pallidus, and now you see the emerging of voluntary movement because you no longer get that inhibition of the thalamus. So what happens sometimes is that we get in a disease called Huntington's disease damage to the globus pallidus. Now remember, the globus pallidus is normally inhibiting the thalamus, inhibiting the thalamus, inhibiting the thalamus. If it gets damaged, then all of a sudden we get a ton of involuntary movements going on. So if it's not inhibiting the thalamus all the time, it doesn't suppress a bunch of movements. And so we start to get involuntary movements, and we'll start talking about that later when we talk about Huntington's disease. And here we are, objective 6, where we talk about Parkinson's and Huntington's disease. First, Parkinson's disease. The symptoms of Parkinson's disease are tremors, rigidity, stiffness of the limbs and trunk, and slowness. And so this is mainly a disease of being unable to do what you want to do. So you want to do something, but you freeze up. So I want to get out of this chair, but I'm frozen and I can't do it. So they have trouble initiating movements. There are a range of other problems that go along with Parkinson's disease, including cognitive problems and depression and things like that. The cause of Parkinson's disease, we've talked about before, is the loss of dopamine producing cells in the substantia nigra. Now, normally the substantia nigra is going to provide input to the caudate and putamen, which, remember, shuts down the globus pallidus. What happens is that the lack of input to the caudate and putamen leads to, in fact, the caudate and putamen not shutting down the globus pallidus. So we get a greater inhibition coming from the globus pallidus to the thalamus, and then therefore to the motor cortex. So what happens is people can't move when they want to move, because we're not getting that caudate and putamen active, which is going to cause us to be able to do the kinds of voluntary movements we want to do. There's a video on that if you'd like to watch a little bit more. Here again, we see these substantia nigra down here in the middle of the brain, and there it's feeding up into the basal ganglia. There you can see the caudate and putamen, the connections there. So how do you get Parkinson's disease? There's an early onset version of the disease. This is very rare. It occurs before 50. It's by far not the most common way of getting it. Usually most people get it after 50. But if you do get it early, there's a strong genetic basis for that. So it tends to run in families if you get it early. But the late onset version has pretty weak genetic evidence and is probably caused by some combination of environmental toxins. We know that there was a bad batch of heroin that came out, I think in the 1990s, and that caused Parkinson's disease in very young people who took it. And they found that it had a toxin called MPTP in that heroin, just in the way that it was produced on the street. It had a toxin in it. And so that turned out to be a good model for Parkinson's disease. And they still give that toxin to animals to give them Parkinson's, so that we can do testing on them and find out what works for Parkinson's disease. There's also evidence that pesticides, herbicides, and even marijuana, in fact, make Parkinson's disease more likely. The nice thing is that if you smoke tobacco, cigarettes tend to be protective against Parkinson's disease. We don't really know why. So is coffee. I'm a big coffee drinker, used to be a smoker, but now I just chew Nicorette gum. Okay, so how do you treat Parkinson's? L-Dopa is a drug that's used to increase the dopamine you have. Basically, it's a dopamine agonist. But it kind of sucks as a treatment because it doesn't keep the dopamine cells from dying. They just keep dying, and therefore it doesn't work in patients that have a lot of cell death. On top of that, it's got a lot of annoying problems. You can get hallucinations, sleep problems, all kinds of stuff. Deep brain stimulation is another possibility. They put an electrode into the basal ganglia and stimulate it using electricity. And that does seem to help for a lot of patients. But again, once your dopamine neurons just completely die out, that's not even going to work. So it works for a while, basically. People have tried transplantation of stem cells, embryonic stem cells, or stem cells from your own body. And it looks like there's some release of neurotropins, and it holds some promise, but I can tell you again, probably not going to be a viable treatment at this point. Unfortunately, it's a progressive disease. My mother has the disease, and it eventually does just get worse and worse. You can treat it a little bit, but it will continue to get worse. Okay, finally, let's talk about Huntington's disease. Huntington's disease has a lot of involuntary movement. So you might get a lot of this kind of thing, twitches and tremors and crazy things. They used to call it Huntington's chorea, which meant from Korea, like choreography, a dance. And it's just uncontrolled movement. And there's a lot of psychological problems having to do with it as well. It's when cells in the basal ganglia, particularly the globus pallidus, start to die. It is caused by a dominant gene. So if one parent has it, you've got a 50% chance of having it. But you don't get it until you're around 40 years old, so you won't know unless you get genetic testing. And a lot of times when people have babies, they don't even realize that they have it, and then all of a sudden they get it when they're 40, and then their kids are susceptible. So they do have a genetic test that will tell you when you're going to get it, if you are going to get it. Here's a video on Huntington's disease, and that's going to be your activity. You guys have a great day. It's been fantastic talking to you. Hope you